Yo, yo, Algebrainiacs! Welcome back to the Johnson Kendra Video Hour!
But it's not an hour.
Alright, today we're going to be multiplying and dividing radical expressions. Okay, here's the basic rule. If you have two radicals...
We're pretty radical.
Yeah, well, we are two radicals, but we're not too radical. If you have two radicals with the same root number, the n there, you can put them together and multiply underneath. So, an example would be this. Now I can take square root of 3, square root of 12, and make it the square root of 36. And then we all know and love that as the number 6.
Do we need to do the plus and minus thing here?
No, we don't.
Okay.
Nope. With the radical already in there, you just give the positive.
Alright.
Alright, this one, they're both cube roots. So, I need to take the cube root and put 3 times negative 9. So that'd be the cube root of negative 27. And cube root of 27 is 3. And the negative has to stay with it because it's odd. So we keep the sign.
So negative 3 times negative 3 times negative 3 would be negative 27.
Right on. Okay, the fourth root. We're going to do fourth root of... multiply these two, I get negative 16. Now, can you take a fourth root of a negative? Are there 4 numbers that will equal a negative?
Only if we use eyes, and I don't think that we're doing that right now.
No, so there is no answer to this. There's no real answer to this. So we just say, nope, can't be done. If it's an even, it has to be a positive number.
Or no real root.
Right, or you say no real root. Alright, this will be like we did in the last lesson. We're going to split them up. Square root of, here we go again, square root of 72 and square root of x to the third. 72 we're going to break into, let's see, 36 and 2 are the two that I come up with. 36 is the biggest. And root 2 we can't do anything with, so we just leave it. Now, this is the square root of x to the third. So I can take one set of 2 out, but there'll be 1 left over.
Oh, because before we would just took that exponent and we divided. Yeah.
Right, so I can take these 2 out, and they become an x. This poor little guy doesn't have a buddy to go outside with. So he has to stay in the house.
You can't play outside. So
can't play outside. So this is what we have. Now you can put your outsides together to make 6x. And you can put these 2 together by the rule we just learned. And we'll leave it as 2x under the radical.
That's pretty cool.
Yeah. Alright, let's try another one. I'm going to get a different color.
Yeah.
I'm going to get all fancy. Alright, square root of 80 and square root of x to the fifth. 80, I'm going to break into, let's see.
I know 4 would work, but I'm guessing there's something bigger.
Got to be something bigger. 4 times 20.
So therefore 4 and 4. 16.
16 times 5. So 16 and 5. And then how many pairs can we take out?
2.
1, 2.
With 1 with no buddy.
Right, so the little buddy guy has to stay underneath. We get x squared. 2 of the x's come out, and the other guy has to stay under. So this is 4, square root of 5, x squared, and square root of x. Outsides give us 4x squared. Under the radical gives us 5x.
I like this stuff.
I do too. Kind of cool.
Alright, here's a combination actually of multiplying and simplifying. And we're going to put, just like Mrs. Kendra just did, we're going to put our outsides together and our insides together. So 3 times 2 will give us a 6 on the outside. Underneath we're going to have 7 times 21.
47.
That's, yeah, I think you're right, 147. And, okay, x to the third and x to the third, that's actually x to the sixth because I'm adding the exponents. And there's no y over here, but I got a y squared, so I'm going to throw that underneath there.
Oops, y squared.
Oh, I said it, but I don't think I wrote it. Y squared. Okay. Alright, now, I did multiply it, but that's not necessarily simplified. So now I need to do, well, it'll be 49. Hang on one second. So we got 6 on the outside. I need to work with root 147. So I'm going to come over here and do that first. I wasn't sure what to use, but I saw that I had a 7, and then I know 7 is also a factor at 21, so then I knew that 49 had to be a factor, and it would be 49 and 3, which is 7 and root 3. Okay, now I'm going to do my letters. I've got x to the 6th and y to the 2nd. Remember, this is a square root, so we're looking for groups of 2, and those actually will, everybody's got a buddy.
Yeah, nice.
So 3 x's will come out and 1 y will come out. There are no people trapped inside. So let's reorganize our stuff. I have a 6 from the outside. That was already there. I'm bringing this 7 on the outside. These guys are on the outside, x to the 3rd and y. And then the only thing trapped on the inside is the square root of 3. Last thing I should do is put those together. So 42 on the outside, x to the 3rd y, square root of 3.
And we probably should put it alphabetically too, so we all have the same answer.
I was going to say, I thought x did come before y.
Yes, it does. I'm praising your work.
Got it, got it. All right, Mrs. Kendall taught us a multiplying rule, so I'm going to teach you a dividing rule. It's very, very similar. It says that if you have two things with the same little root, it's called an index, you could put them underneath the same radical, and this actually, we're going to use this a lot. If you try putting it under the radical, what that allows you to do is simplify the fraction first, and a lot of times that can make your numbers smaller, and therefore easier to work with. So let's do a couple of those. So right now I have square root of 243 and square root of 27. Neither of those are perfect squares, but what I'm going to do is throw them underneath the same radical and make it 243 over 27 and just focus on the fraction. And when I do that, that is...
Let's see. 243 divided by 9 is 27.
So
we could
9
do 9 over 1.
Okay. So that gives us in the numerator just a 9, and actually the denominator ends up being a 1. That's a square root of 1. That's just 1, so we don't even need it. So look what we have, square root of 9, which is just going to be normal 3. But I wouldn't have been able to come up with that if I didn't know that that could be reduced. So let's try another. So this one has variables. Again, I'm going to put them underneath the same square root and focus on just simplifying the fraction. So 12 divided by 3 is 4. X to the 4th and x to the 1st. Remember, you're subtracting those exponents, so that's x to the 3rd. Now I want to simplify. I'm going to split it up. Square root of 4, I know that. That's 2. And then this is 3 x's. One pair's coming out, and one guy's trapped inside. So there's our simplified version.
Nice.
Are you ready for a new rule?
We have a new rule. It's going to rule your world.
You can never, ever, ever, ever leave a radical in the denominator.
That's just a math faux pas.
Right. Breaking the laws.
Breaking the law with a faux pas.
Okay, so what that means.
Ooh, there's one in the denominator.
Yeah.
Get it out.
Not
Hurry,
allowed.
hurry.
Not allowed. Okay, so you always want to check to see, if it's like the problems that I just did, if they both had roots on them, you'd want to see if maybe you could simplify that fraction, but the one doesn't have a root on it. So the only way you can get rid of a root is if the bottom has a perfect square. And we're actually going to make it into a perfect square by multiplying by itself. So square root of 2 goes on the bottom. But you can't just pick like a random thing and multiply. You got to do it over itself.
I like to call that a useful form of 1.
Very good. All right, then you're going to multiply straight across in the numerator and straight across in the denominator. 1 times root 2 is just root 2. And then root 2 times root 2, remember you can put them underneath the same. 2 times 2 is root 4. Why is that helpful?
Because square root of 4 is just a plain old 2, and now there's no radical down there.
Okay, this is the simplified version. Mrs. Kendall, when you teach the trig, how much do you use this?
That exact number right there?
Or using this concept?
Oh, we use it probably 3 to 4 times a week.
That's awesome.
Yeah, because root 2 over 2 is a very fancy number in trig.
Cool.
Yeah.
I remember.
Yes,
Yeah.
the unit circle.
All right.
We get triggy with it.
Okay. Look underneath to see if it could be simplified.
Cannot.
I don't think it can, but it's a nice thing to check for because sometimes it makes your life easy. So again, the problem is the guy on the denominator. That's what you want to multiply by. Root 3 over root 3. And we're going to go straight across in the top, straight across in the bottom. 2 times 3 in the top, that's going to be 6. 3 times 3 in the bottom is going to be 9. Then try to simplify. You cannot simplify square root of 6, so that's got to stay. And then 3 just goes on the bottom. Can I divide the 6 and the 3?
Because square root of 6 is like 2.7 or something.
Yeah, and they either have to both be in radicals or both be out.
Right.
To simplify. Okay, let's do this one. This one actually we can simplify. If you put it underneath the square root first, we could cancel out one of those x's. So I'm going to do that right now. That gets us x to the second in the top, and then just 5 and y in the bottom. And when I do that...
So you can split it back into 2 pieces
Yes.
after you put it into one?
Oh yeah, that rule works both ways.
Forwards and backwards.
Right.
All right.
And that might be helpful because look at this now. What do we have on the top?
Ooh, that's just a plain old x.
Yeah, that's perfect square. So that's going to be x over square root of 5y. Now this is still illegal because I've got a radical on the bottom. So we multiply by the denominator over itself. Useful form of 1, according to Kendra.
Yep.
On the top, x has got to go on the outside because that's not in the house. And then 5 and y are inside. On the bottom, 5 times 5 is 25. And then y times y is y squared. And the whole goal of doing that is for us to get something that is a perfect square. So final answer, x root 5y over 5y. And something I like to stress when we teach this stuff, a lot of you are maybe not going to see these things like this right away, and that's okay. But in the very end, you got to make sure that everything is pulled out of the radicals and everything is reduced in the fractions. You should even check here to see if anything could be canceled. That's typically where people run into trouble.
And I'm noticing the 5y, 5y, both under the radical, you end up getting just plain 5y.
Yeah.
Does that happen every time?
It does. If you look, we ended up with, let's scroll past it now, but, okay, we had root 2, and we ended up with plane 2. We had root 3, we ended up with plane 3.
Oh, so a little shortcut there.
Yep. And that's because we created that perfect square. So here's a challenging one.
Ooh.
Okay, so they're cube roots. I want to try always to simplify the fractions.
Oh, you can a little bit.
Yep, they're both divisible by 2, so at least we can do that. That'll help us out. And I'm going to split it back up. So 4 divided by 2 is 2. 6 divided by 2 is a 3. So now we have this. Now, when we did all these others, we were getting perfect squares on the bottom.
We need a perfect cube.
Yeah. So to do that, we're going to do that useful form of 1. But we're not just going to do it once, because that would create 3 times 3, which is 9. That's not a perfect cube. We actually have to do it twice.
So there's 3 of them for a cube root.
Right. Make a total of 3. Still going straight across in the numerator. So 2 times 3 is 6. Times 3 is going to get me my 12. And then...
Wait, 3 times 3 is...
Oh, 6 times 3. I'm sorry. I thought we were doing a 2 at the end. I thought it was 2 times 3. 18, and then 2 x's, right? X squared. All right, on the bottom, 3 times 3 times 3. Now we have a perfect cube. That's 27. And I also have 3 x's, so x cubed. That's helpful because now I have that perfect cube on the bottom. 18 x squared, that actually cannot be simplified because of the cube. This is just going to be 3x. That's our answer.
All right, so cubes, we got to do it 3 times.
Yeah, we don't see very many of those, but we do need to know them.
All right.
I think we got one last thing to do. This involves some adding and subtracting.
All right, the main thing you got to remember is they must be the same number under the radical. Okay, you cannot add, like you can't add a plus b. You can add a plus a because they're the same. These act like your a's and your b's. So if they're the same, you can add them. A plus a is just 2a. Root 2 plus root 2 is just 2 root 2.
Oh, almost like variables or something.
Yeah, they are just like variables.
Okay. Well, let's use that.
All right. So this one, I see a 3 out front. I'm going to distribute first. So 3 root 2 plus 3 root 40.
Now, wait a minute. Those aren't the same, so you can't add them.
Nope. so I have to do some finagling here and try to get them the same. I see the 40 can be broken into, we'll say 4 and 10. Okay. Let's see what happens with this. So I have 3 root 2 plus, now this is a 2 and a root 10. This 3 and this 2 are on the outside, make a 6. This root 10 is underneath. Now, can we add those now?
No,
No. So sometimes that's as far as you can go.
but we don't know unless we simplify.
Exactly. So you gotta just keep going. All right, last one here. Ooh, I see that radical at the
New
bottom.
rule, new rule, new
Ugly,
rule.
ugly, ugly. We gotta get rid of it. So I need to multiply top and bottom by root 7. Root 7, root 7. The thing I have to be careful of is to distribute on the top. So on the top I get 3 root 7, and then this root 7 times that root 7 is root 49. And then on the bottom, root 7 times root 7 is root 49. Let's simplify. 3 root 7 plus 7 over 7. Now, are there any things alike there that we can put together?
No, but you maybe should look for heart surgery.
All right, let's test heart surgery. Let's test your heart. Do they all 3 have something in common?
No.
No. So heart surgery doesn't work either. So this is as good as it gets. 3 root 7 plus 7 over 7. All right.
I think that's it.
All right.
They're ready to go.
Ta-ta for now.
See ya.